Hey, welcome back. This once more is Dr. Izad here for you with another video in my series about how video game design programs can be leveraged to provide authentic applications of content-related skills, specifically with respect to language arts and the Unity game design engine. In my last video, I reviewed the coding language utilized by the Unity game design engine and how teaching elements of that coding language, which by the way is C#, can fall under the language arts umbrella. This video will follow from that, going over a more complex C# script to provide more dynamic movement for the character so that other scripts for dialogue systems can be called upon to display dialogue between characters, thereby encompassing both language and written narrative standards. You may notice that I have a walking animation applied to my character, and the code to get him to move will work with or without it. And since I haven't really perfected the art of applying different animations yet, as evidenced by the fact that my character is consistently using the walking animation, I will direct you to this video to demonstrate how to apply the walk and idle animations. This individual also provides another code to get a character to move, but as I said before, this one that I'm about to show you works with or without the walk and idle animations, and it can also work with any type of character you choose to include in your game. It is also simpler to understand, albeit a bit more complex than the code I demonstrated in the previous video, and is thus good for students to become acclimated to the coding language. As you may have noticed in this clip here, you can see that the movement of the character is far more dynamic, not only because of the walk animation, but also because the character can rotate left and right as the camera follows. So let's begin by reviewing the code that was written in order to achieve this effect. Before we do that, however, keep in mind that much of what I have gleaned about the rules of the coding language was learned not only by being explicitly told in tutorials, but also by looking at certain segments of the code in context with respect to the outcome it yields in the game, which is essentially what students will be doing as well. So we'll start off with a bit of vocabulary here by defining float, as there are 4 public float variables in this code. Float variable simply denotes any numeric value that includes a decimal point. You can very easily replace each instance of float and replace it with int for integer, and can just put whole numbers in its place, and the code should work just fine. These numeric values can be associated with different things, such as energy bars, and in this case, the speed at which certain events occur, as you will see later on in the code. We've also assigned a name for each float variable, the first one being speed, which will refer to the speed at which the character will move forward, the second one being jump speed, which will regulate the jump movement of your character, the third one being gravity, which will have to do with gravity acting upon your character after jumping, and the fourth one being rote speed, which will determine the speed at which the character rotates. And this just calls on the character controller of the character to whom the script is attached. And then I have an if statement, the if statement being a statement that presents a condition. In this case, the condition is if the controller with whom the character controller is associated is on the ground. So if there's a platform beneath the character, and here I am giving the program a series of commands to carry out if that condition is met upon certain key inputs. Notice also how I did not use getKeyCode down here as I did in the first video, indicating that there are multiple ways to communicate the same things to the program, thereby requiring critical thinking skills. So the first line of code that is highlighted here is dictating your character's movement along the 3D plane if the up and down arrows are pressed. Those are the buttons to which the input get axis vertical refers. And keep in mind that I may not be going over each line of code specifically, as I myself am still learning the coding language and figuring things out, not only based on the explanations provided by various YouTubers, whose explanations, by the way, are not always helpful as they use a lot of jargon, but also through observation of the results achieved through application of the code, application of my knowledge of the English language, and even mathematics and science, and my tinkering with the code, as I shall demonstrate momentarily. Your students can likewise use existing scripts like this as scaffolds, tinkering with certain bits of it to progressively make strides in learning the coding language. So moving down to the third line highlighted here, we are invoking the float variable we created before as the speed of the movement in the direction in which the character will be moving within the three-dimensional plane will be determined by whatever float variable you assigned to speed above in the namespace. And if you look at the code logically with respect to how it is structured, you can deduce that in the following two lines of code, I am introducing another condition to prompt an action to be executed if the preliminary condition of the character with whom the character controller that is called is associated with is met, and that action is to jump. And we get the character to jump by calling upon the float variable that we name jump speed, and when the character moves at that rate, it will move upward because we designated that it is moving along the y-axis. This will occur when the jump button is pressed, and the jump button by default is the space key in Unity. Therefore, inputting jump as the button will automatically register as the space button in the game design engine. Now, while we are on the subject of axes, I would like to draw your attention to how the program registers our input of the up and down arrows, which are, once more, the keys to which input getAxis vertical refers, as being a command that makes the character move forward and backward on the three-dimensional plane. Notice the syntactical structure of that line, and pay attention to where that piece of code describing the input is placed. Can you guess why it would make the character move forward and backward as opposed to up and down and from side to side? If you guessed that it is because that piece of code for the text input is in the place of the z-axis in the three-dimensional coordinate plane, you would be correct. As such, the character will move along the z-vector. Let us now see what happens if we change that input and place it in the stead of the 0 that denotes the value for the y-axis. I am now pressing the up arrow key, and notice how it appears as though my character is attempting to jump. And can you guess what will happen if we place this in the x-axis? I am once again pressing the up and down arrows, and the character is moving from side to side on the x-vector of this three-dimensional plane. So again, because we want the character to move backward and forward, we will need this piece of script written in place of the z-axis to tell the program that when pressing the up and down arrow keys, the character is supposed to move along the z-vector. And this line of code is just indicating how long it will take for gravity to act on the player after it is jumped, since it has to have gravity acting on it in order for the player to come back down and be grounded once more. Now let's look at these lines of code, and you can logically infer that this is the code that I use to make the character rotate. You can also logically infer that if input getAxis vertical refers to the up and down arrow keys, then input.getAxis horizontal would refer to the left and right arrow keys. And notice once more the placement of this input, as we want the character to rotate around the y-axis like so. This may seem confusing for one because we want a character to rotate left and right, and one might reason that the rotate should be on the x-axis. But remember, when using the transform rotate, it is denoting around which axis the character will be rotating. So if it is rotating around the y-axis, the character will move as such. But if this line of script were written in place of the value for the x-axis, the character would rotate like this. Let us see how that plays out in the game. I am pressing the right arrow, and notice how the character is now appearing to do a flip. So let's put this bit of code back in place of the y-axis, so our character can now move along the 3D plane to interact with the non-playable characters, or NPCs, And I'm going to show you how to create a dialog system, as well as briefly review the code for the dialog system, the more salient portions anyway. Once again, I'm learning the coding language myself by applying my knowledge of language and tinkering with bits of the code and observing its subsequent impacts. The idea is that if students see certain segments of the script used in various contexts, they will develop a working understanding of when and how to apply those segments of the script, thereby progressively and systematically learning the coding language. So the first thing we have to do is create a game object to house our dialog system, and the script applied to the NPCs will call on this system when dialogue with the NPCs is initiated. In other words, we are creating the things that will be displayed to denote what characters are saying when our playable character is talking to the NPCs. So this is my dialog system, and I have several components under my dialog system, and they are there for specific reasons, which I will explain momentarily. The dialog system is essentially an empty game object that I created from this dropdown, and I had named it dialog system here. And I did the same for every component that is under the dialog system, such as the Dialog Gui, which is a canvas that I created. The canvas basically provides a space on which other user interface or UI elements can appear, and the UI elements can be used to create pop-up dialog boxes, as I have done. You see I have my chat background here, which is a renamed UI text element, and within that text element, I'm going to have two more UI text elements. The first of which I've denoted as name, and the second of which I have named dialog text. I did this specifically because when the dialog box appears, I want the name of the character speaking in one specific area, as seen here when I go into the 2D view and click on the chat background. So the name will go up here in the top left, and the dialog will go in the middle, and you can adjust where each one appears when clicking on the chat background. Just make sure Dialog GUI is checked here so that it will be visible. It will be invisible otherwise. And this is the code for the dialog system, and as you can see, it is pretty lengthy, so I will not be going over this. Rather, I will be linking you to a video right here, and this is the video from which I retrieved this code. And this YouTuber does a good job of explaining the code line by line. He also reviews the code that will be attached to whatever NPC the player will interact with, and I'll also go over specific parts of that, just as I did with the previous code that was intended to get the character to walk forward, backward, jump, and rotate. And this is that code of which I just spoke, and I'm going to breeze through this a bit because, as I just stated, the video that I had linked explains this code line by line, as well as the code for the dialog system. So including these things in a namespace and making these variables public will allow for them to appear here under the script. And this is where you will denote what appears in the name text box and dialog text box, which were UI elements that we created under the canvas in our dialog system game object. This segment of code here will indicate the position of the dialog text with respect to the NPC's position. These are numbers that the students can definitely manipulate, depending on where they want their text boxes to appear. This piece of code is important since it sets a condition that will prompt the dialog system to run, and that condition that must be met is if the character approaching the NPC is tagged as a player. And this is important because you have to make sure your player that you want to make talk to an NPC when F is pressed is tagged as a player right here. And over here, if the character that the player is in range of is an NPC when the F button is pressed, it will call on the dialog system and all of its subcomponents. And this just tells the dialog system to stop running if the playable character moves out of range of the NPC. So now let's see how to apply this script to the NPCs. So I have scripts already applied to many of my NPCs, but I will select one to which I do not yet have a script attached, and that is the Night Warrior. Once you have the character selected, you can either drag and drop the script and add it as a component under the inspector on the right, or you can drag it onto the character's name in the hierarchy on the left. And you will see that script appears under the inspector either way. Notice how our public variables appear here as well. And we will now go to our dialog system and drag the chat background from the dialog system in the hierarchy into that space next to the variable under the script here. And we also have to drag the character to whom this script is applied from the hierarchy to the space under the script where it says NPC character. And this public variable pertains to the text box that we created under the dialog system for the name of the character, and this is where we will type in the character's name so we know who's speaking. And the number that we input next to size will determine how many pieces of dialogue each character will speak. And I want this character to say 3 things that will fit in the space designated for the dialogue, and 3 boxes will appear below that. And then you'll just type what you want your NPC to say. And one more thing you have to be aware of. Since the code prompts the dialog system to run and appear when F is pressed within range of an NPC, we do have to add a physics component to the NPC, and that is the capsule collider. We're just going to change the radius to 0.6, and that will determine how much distance between the playable character and the NPC will constitute being in range, and we will make this a trigger. If you don't do this, the dialogue text will not appear on the screen when you press F next to an NPC. And now, when we move up to this character and press F, his dialogue appears. And the last thing I want to mention is the creation of animations for your NPCs. Granted, some characters you may download from the asset store come complete with different animations for idling and walking and running, etc. You'll also be able to create your own animations for certain NPCs depending on the download. And you do that by clicking on the NPC and then going to the animation tab here. And you're going to want to open up all of the child components for the character's rig. These will consist of the character's different body parts, which you will be able to individually move and rotate in order to create an animation. And just like we did with the camera in the first video that I made in the series for the opening cutscene, we will be recording animation events based on the movements of the specific components of the character's rig. This animation should be appropriate to the story, so I'm going to create an animation, subpar though it may be, to indicate that this character is distressed, being that her home is among those set ablaze by the king. So I'm going to add a series of animation events, and in between each event, I will rotate her head one way or the other in between each of those events, so it looks as though she is shaking her head in distress. And then when you play the scene, you'll see that the character's animation is applied, and the dialogue complements the animation as she informs you as to why she is distressed, thereby advancing the plot. And although this is still a work in progress, what we have here is a developing project that allows for application of these skills, among others. Of course, as we are creating a story, all of the narrative writing standards apply, but we specifically were focused on creating dialogue to move the plot forward and incorporating precise language in that dialogue, and even figurative language, to accurately convey what you want to convey. And we have all of these multimedia elements to emphasize certain things, the animations of the characters indicating that they're in distress, the fire effect added to the houses, and the fire sound effects to amplify the sense of chaos. And we even focused on these language standards, as we were applying knowledge of language to tweak the pre-made code, which is a complex text that could act as a scaffold in order to communicate and realize expected outcomes for different game elements. Essentially, all of these skills are being applied to a context that could result in careers for students, and that is rather the purpose of school, equipping students with skills to prepare them for 21st century job markets. And there will be more to come on this project exemplar soon. And remember, if you like this content and find my ideas agreeable, please like and comment, and if you feel so inclined, please subscribe.